Hello everybody, this is Cap here, and I'd like to welcome you to the 10th video in my C++ containers tutorial series. And in this video we are going to be going over priority queues. So priority queues are like queues, except with queues, the first thing you push onto the queue is the first thing that gets popped off the queue. But with priority queues, after you push something onto the queue, it then rearranges the queue and puts them in order from greatest to smallest. So the next thing that gets popped off the queue is the greatest that is in the queue, which you'll understand what that means here in a minute. So first you need to make sure that you have queue included, and then to create a priority queue we can just say priority queue. We'll make a priority queue of ints or integers and give it a name. So a priority queue is actually a container adapter. So it has an underlying container, and by default this underlying container is a vector. So if you want to be really specific, you can say vector int, and now we specifically said that we want the underlying container to be a vector. You can also make the underlying container a dec, but as I said, by default it is a vector. So let's go over a few methods. First, there's the push method to push things onto the queue. So we'll push on 12, and say 22, and 1. Next, of course, we have the ones that we usually have, which is empty. Say pq.empty, and that tests whether or not the priority queue is empty. And we have pq.size, which gives the size of the priority queue. But since we won't be using those right now, I'll just go ahead and erase them. Oh, and there's also pq.swap, which swaps the contents of two priority queues. But let's go ahead and print out this priority queue. Okay, so we're going to say pq.top, which gets the top element of the priority queue, which would be the greatest element. And then we're going to say pq.pop, which pops the top element off of the queue. So we are pushing these three elements onto the queue, and then it should rearrange them to where it is 22, 12, and 1. And then we're going to loop through, get the very top element, pop it off, get the top element, and pop it off until the queue is empty. So let's run it. And as you can see, it did rearrange the elements, which is what a priority queue should do. But priority queues aren't just good for integers. You can actually use your custom objects with a priority queue. So we'll go ahead and erase these, and I'm just going to change this to .speed. I've created a car class, and this is also a good opportunity to go over the inplace method. So instead of constructing objects, giving them a name, and then pushing them onto our priority queue, we can use the inplace method to construct and push them onto the queue all at once. So we can say pq.inplace, and I'll give it a speed. Since it already knows it's a car, we could just have to pass in the parameters that it needs for the constructor. So we'll say 20, and we'll say it's a truck. Q.inPlace 40. Oh, we'll say this is also a truck. And then PQ.inPlace 120. We'll say this is a car. Okay, now if I actually run this right now, it won't work. As you can see, we get an error. And the reason we're getting an error is because the priority queue doesn't know how to compare our classes, or our objects. And the easiest solution to this is to overload the less than operator. Which, if you haven't seen my tutorial on operator overloading, I would highly suggest you watch it, because it's very useful. So if we come down here and we'll just say bool operator const car, and we'll just say it's C1 const. Alrighty, and yeah, we'll make this easier on ourselves. Doing that. And all we really have to do is say speed less than C1 dot speed. So now the priority queue will have a way to compare our objects, and it will compare them by speed. So it should put the object with the greatest speed at the top of the queue and the object with the lowest speed at the bottom of the queue. So we'll come back here, we'll make sure everything is saved, and then we will run it. And as you can see, it did put our objects in order from greatest to smallest according to their speed, because that's what we told it to do. And that's really all I wanted to go over in this video. If you like this video, please let me know by hitting the like button. If you've seen a few of my videos and really like them, you can go ahead and subscribe and see when I post new ones. And I would like to thank you guys for watching, and I will see you in the next video.